This is slide number 9 and I am your presenter Asloob Mudassar. You see that in the previous slide we have discussed two types of targets. One was the spoke target and the other one is the US Air Force resolution chart. Now we are here we are presenting another type of resolution target. You see that in the target on the left side the spatial frequency is very small, but as we move towards the right the spatial frequency, that is line pairs per millimeter, starts increasing, and at the right end we have the maximum value of that target. Such a target can also, can also be moved along the object plane, and we can obtain any desired spatial frequency which we require in our optical systems. So this is what we can obtain with a variable line frequency, with a variable spatial frequency can be obtained using this object. Here we have two-dimensional cosinusoidal gratings. You know that cosine signal goes from -1 to +1. So actually this is we have drawn the sine functions in two dimensions, but not cosine functions. Actually 1 plus cosine functions, so that we do not get the negative values there. So this is on the left we have in the square aperture cosinusoidal gratings in the square aperture, and on the right hand we have the sinusoidal grating in the circular aperture. In both these pictures we have the same spatial frequency, and you know that cosine and sinusoidal signal and the sinusoidal signal both have only one frequency. So this is one frequency we have shown, and we have shown the reasonable value of the low frequency so that we can view the fringes very easily. So this is our object, that as a two-dimensional cosinusoidal gratings. So single spatial frequency with varying amplitudes. Of course, you know that if we have a cosinusoidal signal, it will have a single frequency, but of course the amplitude will vary, and in this case the amplitude vary from 0 to +2. And on the lower side, so amplitude transmission gratings with the spatial frequency beyond 500 line pairs per inch act as a useful diffraction grating. So these gratings can be used as input objects for our optical systems, and if we have a grating with more than 500 line pairs per inch, that grating will be very useful in order to demonstrate the diffraction effects and in order to analyze such systems. So here now there is another type of object which we call phase objects in the transmission mode. Phase objects change only the phase of the incident light through them, and amplitudes are regarded as nearly unchanged, because such for example, if you have a glass plate of a varying thickness, the light will pass through the glass plate, but the amplitude of the light will not change. So the amplitude will remain nearly constant, but you know that due to the varying thickness of the glass, what will happen, the phase value at the output of that object will change. So such objects will be referred to as the phase objects in the transmission mode, and we shall be talking about, I think, with more detail in the next slide. And here this is the end of slide number 9.